My name is Isaac Ray, and I'll be introducing TackleBox, a Python package for improved handling of PyTorch module hooks. If you aren't already familiar with PyTorch, see pytorch.org/tutorials for some great introductory videos. Modules are the fundamental building blocks of PyTorch models. The forward and backward pass of a given model is made up of an iteration of forward or backward passes of the individual modules that model contains. PyTorch modules can have hook functions registered on them so that the functions will be called at various points during the module's forward or backward pass. There are three main types: the forward hook, forward prehook, and backward hook. These hooks allow inspection of the behavior of individual modules in a network during its training or evaluation. Let's look into these hooks in a little more detail. The forward hook is called after a module's forward pass is complete. The function is passed the module, the input received during the forward pass, and the output. The module has the option of modifying the output and returning it, in which case the modified output will be passed on to the rest of the network. The forward prehook is called before a module's forward pass begins. The function is passed the module and the input that it is about to receive. The function has the option of modifying the input and returning it, in which case the module will operate on the modified input during its forward pass. The backward hook is called after a module's backward pass is complete. The function is passed grad_in and grad_out variables that correspond to the gradients with respect to the inputs and outputs of the module's forward pass, respectively. Module hooks are incredibly powerful tools for deep learning research and can be used in many ways. For instance, a forward hook could be used to analyze a network's intermediate activations, or freeze early layers by cutting the computation graph, or even insert additional layers into an existing network. Hook registration in PyTorch is traditionally done by calling a module's hook registration method, passing the hook function that is to be registered to that module, and returning a handle that can be used to remove that hook once you're done with it. In this case, we're registering the function myForwardHook with modules myModule and otherModule. Each time we register our hook to a new module, we receive a new handle that we must maintain until we wish to remove that hook. Because you must save a new handle for every distinct function module pair that you register, your experiment code quickly becomes messy when working with multiple hooks registered across many modules. Another issue is that the gradient tensors passed to the backward hooks are notoriously inconsistent. In fact, this inconsistency led to the eventual deprecation of module.registerBackwardHook in recent versions of PyTorch. TackleBox attempts to resolve these issues. The package provides a hook manager that wraps calls to hook registration and stores the resulting handles internally. The hook manager allows users to register hooks in bulk, then deactivate and reactivate these hooks at any point during model training or evaluation. TackleBox's hook filters allow you to select a group of hooks to activate or deactivate, making it easy to apply your hook functions over an array of modules in your network. TackleBox also solves the issue of inconsistent gradient serving in backward hooks by re-implementing module backward hooks using registration of tensored backward hooks on a module's input and output during the forward pass. PyTorch has begun reworking backward hooks in version 1.8 with the new module.register full backward hook, but for those using earlier versions of PyTorch or waiting for a stable release, TackleBox provides an alternative solution to the backward hook dilemma. To get started with TackleBox, install the package with pip. From there, simply import Hook Manager and initialize a Hook Manager object. We saw earlier the syntax for module hook registration and removal in PyTorch. I'll now show you how this is done with TackleBox. Rather than making a new call to register forward hook for each module we would like to register our function with, we can make a single call to the equivalent Hook Manager method, passing our forward hook function as the first argument and any modules we would like to register it with as keyword arguments indexed by a module ID chosen by the user. These module IDs can be used later on to look up the module and its registered hooks in the Hook Manager's lookup tables. There are equivalent functions for registering forward prehooks and backward hooks as well. When removing TackleBox registered hooks, there are several options to save you time. You can choose to remove a particular hook from all modules it's been registered to, remove all hooks registered to a particular module, or remove a single hook registered to a single module. Regardless of how you choose to remove your hooks, there is no need to maintain hook handles. Finally, rather than remove your hooks entirely, you can simply deactivate them. They will no longer be called at their corresponding entry point, but can be reactivated with ease at any point later on in your experiments. To activate all registered hooks, call the hook manager method activateAllHooks. TackleBox also provides several filtering options that allow you to select a group of hooks to activate or deactivate with a single line of code. To filter hooks by module, call instead activateModuleHooks, passing as arguments any number of modules to be activated. To apply filtering by hook function, pass the hookTypes keyword argument with a list of functions that should be exclusively activated. To apply filtering by hook category, pass the category keyword argument with the corresponding hook category to be activated. Your options are forward hook, forward pre-hook, or backward hook. Both hook types and category keyword arguments may be passed to activate module hooks as well, to enable filtering by both module and hook function or category. TackleBox brings improved organization to your hook management and deep learning experiments, saving you time in hook registration and removal. Please visit the GitHub for a more in-depth quick start guide and check out the website for video tutorials. Thank you for watching.